Okay, so the recording is now on, and we'll continue what we discussed in last Friday. So we were discussing vehicular communication, and this is one kind of midway between the enterprise communication and industrial control network. Vehicular communication is very important for next generation vehicles because they are going to be autonomous vehicles. And even if they are not autonomous vehicles, still there will be a lot of information exchange between vehicles with the roadside infrastructure or pedestrians or other entities, so that we can have better living conditions. We'll start with the idea of smart city. We'll first have a case study of Jaipur. Now, Jaipur was recently considered to be upgraded to a smart city. You probably know that Jaipur is a very city with a very rich heritage, and if foreigners come to India, they probably have this one city in their top priority list because of the historical significance. But when I went to Jaipur like 3 years ago or so, I found that the city is in urgent need of some upgradation of the traffic infrastructure. The Jaipur metro work is going on, and that is putting extra pressure on the traffic scenario of the city. Now, obviously, there are many aspects of a smart city, like you need better drainage, better pavements, better housing, and so on. But we are going to focus on smart mobility because this is where probably information and communication technology, or in particular communication networks, are going to be really useful. So smart city obviously needs one such aspect as smart mobility. Now, for smart mobility, there are many approaches. One approach is like smart parking. Now, why we need smart parking? Well, if you have a arbitrary kind of parking on the side of the roads, then it will not only contribute to the traffic congestion, but it also will have environmental impact. For example, if you can have smart parking concept, then you can increase the greenery in the streets. We will show in few slides how. Now, when you have increased the greenery in the streets, that can reduce a lot of urban heat island effect. Now, what we mean by urban heat island effect? Well, in general, when we consider any urban area or any area which is having a lot of concrete surface, then that area is generally much hotter compared to the neighboring areas, because they capture the heat and they cannot dissipate heat quickly like nature. So this is the next slide shows actually a study which was done 2 years back, and it was a heat map of Jaipur, and you can see that while we have urban areas which can reach a temperature of up to say 44 or 45, there are areas which can be as low as 35 or at least 5 degrees to 10 degrees difference. Now, this is a very common feature of any built-up urban area, and if you can increase the greenery in the city landscape, then probably you can reduce it a lot. And for Indian and other countries like which are hot and humid, reducing such urban heat island effect is a big deal in having the smart city kind of thing. So how we can reduce urban heat island effect, how we can do it with smart mobility, and how communication network can help. So that is shown with this case study. Now, Jaipur Municipality Corporation, or in short JMC, they are building some multi-level parking at Ashok Nagar. Now, obviously, there are many other plans, but this is what I know as of now. Now, what they are thinking about this smart parking or multi-level parking is that they are not going to park horizontally, rather they are going to park vertically. Now, when they are doing this parking vertically, they are assuming that they will have automatic parking facility, and they will have a retrieval time of less than 3 minutes. That means within 3 minutes, you can probably take out the car. But with such kind of automatic parking and automatic retrieval, you require a lot of communication with vehicles. So this is one important aspect of vehicular communication, that you need communication with vehicles, with the infrastructure. Infrastructure, we mean that there are some nodes in the parking facility building or nearby roadside traffic post which can communicate with the vehicle and direct them towards the smart parking facility, and probably notify them how many empty spots are there, and probably guide the cell phone of the driver how they can probably retrieve their vehicle quickly. So this is case study number 1. Now for case study number 2, we are going from the northern part of India to the western part of the India, and we are taking another example of Mumbai-Pune Expressway, which is MPEW in short. Now Mumbai-Pune Expressway is obviously a marvel because it has around 100 kilometers, but it is 6-lane and it has a lot of traffic. Like every day around 85,000 vehicles move on that road. So that's something like a very big achievement. But the worrisome point in the Mumbai-Pune Expressway is that there are around 1.25 deaths per kilometer in a year. So when there are 100 kilometers, then obviously there are more than 100 deaths in a year due to accidents and something like that. And it is often considered that one of the most dangerous roads in India. Now, these facts were obtained from these sources which are written here. So obviously, we have to do something with such kind of road and traffic conditions. So what the authorities are thinking? Well, the authorities are thinking of smart highway concept, and they are employing the artificial intelligence enabled cameras and the speed gun which detects the speed, and also drones. So what they are trying to do is, like, there are speed guns at critical bending points. So they measure whether any car is speeding or not, or whether there is any kind of lane cutting or rash driving. And then they also have cameras in fixed points which can probably capture the image of the car and the number plate. And there are some dynamic things, because you see these cameras and speed guns are generally fixed at a place, but drones can move around, and they are using the drones also to probably dynamically monitor the situation. Then also they have road sensors, and they are installing Wi-Fi along the highway. For that, they are having a dedicated optical fiber cable, and these are done to realize demand-based traffic signaling. What is demand-based traffic signaling? Well, it might happen that in certain junction points or so, or in certain checkpoints, you require probably a red light probably for a larger time or for a shorter time. So that kind of dynamic or demand-based signaling is realized with such kind of an information highway, which is laid in parallel to the actual highway. Together, all these things realize an intelligent traffic management system, or ITMS, and this also requires a lot of communication with vehicles. So we have taken 2 case studies. The first one is the Jaipur city, the second one is the Mumbai-Pune Expressway, and in both cases, although the applications are a bit different, but they require a lot of communication with the vehicle. So that's why vehicular communication is so important. Now we have seen the scenario in India. Let us see the scenario around the world. Well, in Europe, there had been a lot of such activities. Like Europe has already banned the entry of personalized vehicles in the city centers, and they are encouraging public transport. But there are places which are only accessible with cars, so they also consider the importance, and they're trying to improve the car driving as well as vehicular traffic in general. So one action is like on the left hand side, there is a picture of an autonomous vehicle where there is no driver interaction, and the autonomous vehicles are trying to do or navigate through the way, so they are testing heavily. On the right hand side, there is a picture of a smart street light post, which can have a light sensing photocell, it can have image sensor, it can have internet protocol based camera, sound sensor, water detection, seismic sensor, speakers, and digital signage and wireless transmitter. So altogether, they can support a lot of entities like the vehicles, the pedestrians, the bicyclists, and public safety vehicles, and so on. There are 3 consortiums in Europe which are very active. One is the European Automation and Automotive and Telecom Alliance, which is called EATA. The second one is 5G Automotive Association, and then there is Car-to-Car Communication Consortium. So they are working closely with each other, and they are coming up with new standards, new technologies, and new regulations. Let us take a look at Japan, which is also having very advanced vehicular communication features. Now, on the left-hand side, we are showing an automatic toll kind of thing, which is a common norm in most of the Japanese places. This automatic toll collection is coming to India as well, and there are many roads which are enabled with this, where we have, probably this, you already probably have experienced it with smart tag, like you have a RFID tag printed or fixed on the dash, on the windscreen of your vehicle, and that can communicate directly with a sensor which is on the toll gate, and probably you need no human interaction, and the gate automatically opens and probably you can drive through. Then there on the right hand side, we are showing something like pedestrian detection, where we can probably have vehicle to vehicle communication and detection of the pedestrians and all these things. So that is again another area which probably Japanese people are quite working and quite good at this. Okay, now after understanding the scenarios around the world, let us now consider some demands, like in the future vehicles, what are the demands of communication that may rise? Well, I am taking a picture from the Sakaguchi lab, who are working at the Tokyo Institute of Technology, and they are doing something like this. Well, let us try to see the picture carefully. There are three cars that are shown. One is a green car, one is a blue car, and then one is a red car. Now, what is the idea of these three cars? Well, we are assuming that the green car is going to be an autonomous car, and this green car is trying to overtake the blue car. I repeat that the green car is trying to overtake the blue car, and the green car is going to be an autonomous vehicle. So there is no driver interaction. So the car is driving itself. Now, when it is trying to overtake blue car, obviously it may collide with the red car, because the red car is coming from the opposite side, but the vision of the green car is obstructed by the blue car. So the green car cannot see the red car, the blue car can see the red car, and if the green car is trying to overtake the blue car, it may collide with the red car. So what the next generation communication will be something like is that the blue car will help the green car to avoid the collision. How? Now the blue car will have obviously different cameras, and these cameras will detect a picture of the red car, and these pictures will be transmitted real time to the green car. So for the green car, who is like, there are three inset pictures. So on the left hand side, you can see that the green car's normal vision, which is a blue car, which is obstructing the red car. Then after getting the image from the blue car, it will see the blue car as well as the red car as a superposition. So because the blue car is sending the picture of the red car. So on the top of the insert picture, you can see the blue car, this one. This is the blue car, and the red car both are visible to the green car. So this is something like the future demand, like real-time high-quality image transmission. And when you are involving real-time high-quality image transmission, and that too in a mobile scenario, that is obviously going to be a very critical kind of task. So you need a very high-performance communication network. However, we need not to fear, because we have a lot of resources already inbuilt in the vehicles. Like every vehicle is now coming up with a lot of radars, like there are mid-range and long-range radars, there are ultra-short and short-range radars, and there are a lot of proximity sensing. So these things are already built up, and probably more cameras and lidars are going to be built in cars. So we need something, probably an integration framework as well as communication framework, to take help of such sensors. Now, these are some of the next generation vehicular communication scenarios, where we can have something like a vehicle to infrastructure. So this is a cellular tower, and this is a car. So this is V2I, or vehicle to infrastructure. This is vehicle to pedestrian, V2P. This is vehicle to vehicle, V2V. And then there is vehicle to everything, like it can be a traffic post, it can be anything. So there are different aspects of vehicular communications that are going to be probably coming the next generation. Now, what are these kind of use cases? Well, this is again another picture where we're trying to show that this is a crossroad, and on the crossroad there is some like, for example, what I should say, like there is some cellular or tower or something like that, which can communicate with this vehicle, and this vehicle beforehand knows that there is a porthole. So this is porthole detection and warning. Then there is something like a person is jaywalking. He is not following this uh, zebra crossing. So this tower is also going to transmit signal to the vehicle and asking the vehicle to stop because there is some person is probably moving. Then there is an accident already occurred here, and this vehicle is probably turning, and this information is passed to the vehicle, and probably there is an alarm that there's already an accident occurred in the curb section. So these are some use cases which are probably going to be useful in considering such kind of vehicular scenarios. Now we have almost reached to the end of today's slides, and I'll just try to let you know that what at NIT Durgapur we are doing with vehicular communication. We had a very active group, and we had been playing with some concepts as well. Now our concept was something like this. On the left top side, there is a bus, and inside the bus there is a person, or there are multiple persons who are using suppose cellular phones. Now what we thought about is that instead of communicating every person like with a cell phone tower or something, why can't we aggregate the total information within a bus, and we can have a small access point or router kind of thing inside the bus which can directly communicate with a tower in a aggregate manner. So this is going to be a next generation kind of network, and for that we need to make sure that the wireless channels inside a vehicle needs to be studied. So we studied that, and we have got some measurement, we have got some simulation from that, and we have got some design guidelines, and those were published 2 years or 3 years back. And this was a wonderful work done by the undergraduate students of the ECE department at NIT Durgapur. And we had been continuously collaborating with our European as well as US collaborators. So we are very proud to show that we are at par in the vehicular communication domain, and we are working hand in hand with other collaborators. So here actually we stop our discussion about vehicular communication, and there is nothing much to discuss on this topic, so I will stop the recording as well.